Well, hello again, everybody. Mr. Reeves back with you. And we are starting Module 3, Rational Numbers. I bet you guys are excited. We're going to be working with fractions and decimals. We're going to be adding, subtracting, multiplying, and dividing. We're going to be taking what we did in Modules 1 and 2 and applying it to rational numbers. And if you're going, I don't know what a rational number is, Mr. Reeves, don't worry, we'll get there. But today we're actually going to start with the Are You Ready? We're going to be doing a bit of review with multiplication and division of fractions. We're also going to, once again, revisit order of operations, which is so important. All right? So for now, you could just think of a rational number as a fraction. It's a little bit more involved than that, but pretty much when I say rational number, you can think fraction. All right, and coming into Module 3, they expect you to know how to multiply and divide with rational numbers. But I know that sometimes it's good to have a review. So we're going to take some time right now and do a little bit of review with fractions. All right, so first of all, let's talk about what a fraction is. So we're going to put A over B. That's supposed to be a B right there. Let's actually close our letter B, Mr. Reeves. All righty, that's a little better. Okay, so the top part of a fraction is called the numerator. And it tells you how many you have of something, okay? Because it enumerates, so it's the numerator. The bottom part of the fraction is the denominator. And the denominator tells you the size of the pieces. So when you have a fraction, again, if I have the fraction 2/3, that tells me that I have two things and that it takes 3 to make a whole. Okay, so I have 2 and it takes 3 to make a whole. If I have 7/8, that says I have 7 and it takes 8 to make a whole. So if we're looking at the size of the pieces, these pieces are going to be much bigger than these pieces because this only takes 3 to make a whole and this takes 8 to make a whole. Okay? So again, that's what a fraction is. And then we do something called simplifying a fraction. Sometimes we call it reducing a fraction, simplifying a fraction. I like simplifying rather than reducing because reducing implies the idea that it's getting smaller, and actually the size of the fraction stays the same. Simplifying a fraction. Okay, so if I have, let's say I have 24 over 36, and I am asked to simplify that fraction. Okay, well, what does that mean? That means I have, again, if we go back to the meaning that I was talking about over here, it means I have 24 and it takes 36 to make a whole. But maybe I can write this fraction in a different way with smaller numbers where it is still equivalent. So I'm going to take that 24 and I'm going to write it as, let's say, students always like to start with 2. 2 times 12, and then 36, you may not know, is 2 times 18, right? Well, this line in a fraction means to divide, and 2 divided by 2 right here is 1. Anything divided by itself is 1, all right? So when you have A divided by A, it's going to equal 1 every time, as long as A is not equal to 0, because you can't divide by 0. And so we can cancel that out, okay? So I could go right here and say that this is 1. So what does that tell me? That tells me that having 24 out of 36 is the same as having 12 out of 18, right? If I had a pizza and I cut it into 36 pieces, those would be very small pieces, by the way, all right? And I ate 24 of them, that would be the same as if I had that same size pizza and I cut it into 18 pieces, still very small pieces, and I had 12. But I could take that 12 And I can break that one. Again, I'm going to keep using 2's because, again, that seems to be my student's favorite number to divide by. So 12 is 2 times 6, and 18 is 2 times 9. So once again, I could divide that 2 divided by 2. And what does that tell me? That tells me that 24 over 36 is equivalent to 12 out of 18, which is the same as 6 out of 9. So if I took that same size pizza and instead of cutting it into 36 pieces or 18 pieces, I cut it into 9 pieces and ate 6, that would be eating the same as if I had done these, right? But wait, there's more. All right, now if I tried 2 again, it would not work, right? Because 2 does go into 6 evenly and 9 doesn't. But what does go into both of those? 6 is 2 times 3, right? Okay, actually, let me do that. Let me rewrite that as 3 times 2, and 9 is 3 times 3, right? So what do I have right here? 3 divided by 3. Just like I could cancel 2 divided by 2, I can cancel 3 divided by 3. I'm not actually canceling as much as I'm just dividing and getting 1. So what does that tell me? That tells me if I took that pizza and divided it only into 3 pieces, now these are much, much, much larger size pieces than 36, right? All of these, okay, these are all called equivalent fractions. They're all called equivalent fractions. And let me, real quick, I'm going to go ahead and pull up a calculator. Not that I really want you using a calculator for what we're doing right now, but I just want to show you a quick, easy way to prove that they are equivalent. All right, so let me get this out of the way. Let me clear this out. So I'm going to take that first number, 24, and I'm going to divide it, the numerator, by the denominator. I get 24 divided by 36. All right, and what do I get? I get that fraction, 0.6666. It actually repeats forever, right? And then I'm going to take that next one, 12 divided by 18, and watch what happens. I get the same number. I bet you know what's going to happen when I do 6 divided by 9 and when I do 2 divided by 3. I get the same decimal number every time. That proves that these are equivalent, okay? So simplifying a fraction is getting an equivalent fraction where you can no longer divide out any factors other than 1, right? So if I wanted to go one more step, the only thing I could do on here would be to write this as 1 times 2 and 1 times 3. All right, and at that point, it's not helpful. I mean, I can cancel out the 1s or divide out the 1s, and then I'm right back where I are, okay? So just a couple reminders about what fractions are. The number on top is the numerator. It tells us how many we have. The number on the bottom is the denominator. It tells us the size of the piece. In fact, I'm going to go ahead and write that. How many we have. And the bottom is going to be the size of the pieces, okay? Or another way to say that, actually, that's a little better, is how many to make a whole. And the bigger that number on the bottom, the smaller the fraction will be, okay? How many we have is the numerator. The size of the pieces, how many to make a whole, is the denominator. Simplifying a fraction, all right, is dividing all common factors other than 1. I should say, okay, dividing all common factors other than 1 from the numerator and from the denominator. Okay, this is math that hopefully is not new to you. Hopefully you've seen it before, but these are two things you really need to know. The definition of a fraction, all right, so the definition of a fraction You need to know what that is, and you need to know how to simplify, or as we often call, reduce a fraction. Again, though, you're not reducing it, you are simply dividing out all the common factors. In this case, we divided by 2, we divided by 2, and we divided by 3. By the way, one last thing before I end this video. Since we divided by 2, and then we divided by 2, and then we divided by 3, well, let's multiply those real quick together. 2 times 2 is 4 times 3 is 12. We could have divided by 12. We could have done this in one step. I know some of you are probably going, well, why didn't you just do that at the very beginning? Because I wanted to show you this process, right? I could have written 24 as 12 times 2, right? And 36 as 12 times 3. And then I could have divided out those 12s and gotten there in one step. All right. But the great thing is, it doesn't matter how many steps you use. All right. You'll get there at the end. You'll arrive at the same result. So whether you like to take baby steps or giant alligator steps, as we used to call them in Mother May I, yes, you may. All right. You will arrive at the same result. All right. So I'm going to end this first video here. And in my next video, I will talk about multiplying and dividing fractions.